In this video, we will explore how the SpaceX Starship follows 4 key criteria that make it superior to NASA's Space Launch System. The criteria are heavy lift launch capabilities, rapid reusability, sustainable propellant, and low manufacturing and launch cost. With that said, if you would like to expand your understanding of new tech companies that typically fly under the radar, have remarkable investment potential, and are at the forefront of exciting new industries, then please check out our weekly newsletter, linked below. It's 100% free with no cost to you, and who knows, it may contain the ideal stock you've been looking for. Thank you so much for your support. Now on with the video. The ultimate goal of SpaceX is to preserve the light of consciousness by making humankind a multi-planetary species. Rather than putting all of humanity's eggs in one basket, we should evenly distribute the human race throughout the solar system to avoid a species-level extinction caused by nuclear Armageddon, supervolcano eruption, global pandemic, or any other cataclysmic event. We desperately require a vehicle that was engineered from the ground up to take on this monumental undertaking. The 120-meter tall Starship Heavy Lift Launch Vehicle sits atop the orbital launch mount located at Starbase Boca Chica, Texas. As the courageous Martian adventurers find their seats, condensation can be seen forming on the exterior of Starship due to hundreds of thousands of litres of subcooled liquid methane and liquid oxygen flowing into the enormous propellant tanks. Initiating the load and go procedure. As the countdown hits 0, 33 sea-level Raptor engines ignite, propelling the spacecraft with a collective 7,590 metric tons of force skyward. Once Starship reaches the edge of space, the Superheavy Booster jettisons, returns to Earth like a 200 metric ton javelin, performs a propulsive landing, and is eventually caught by the Chopsticks, connected to the orbital launch platform. Starship remains in orbit around Earth and rendezvous with another Starship, configured as a propellant tanker. This is a necessary step, as the majority of the propellant is depleted on ascent. After refueling is complete, the two ships disconnect, with Starship commencing the perilous 236 million kilometer voyage through deep space. Approximately 7 months later, Starship reaches the Martian atmosphere and proceeds to perform a landing flip maneuver, reducing its velocity before safely touching down on the red planet. The doors slide open, and the astronauts are greeted by the rusty brown Martian regolith and the early human settlement. The SpaceX Starship adheres to 4 key criteria that make it fit for purpose to colonize Mars. Criteria 1. Heavy lift launch capabilities. Starship is designed to transport 100 to 150 metric tons, or 100 astronauts, to low Earth orbit, or LEO. This is achieved by simplifying the design and removing unnecessary components such as landing legs, which could add up to 20 metric tons of mass to the rocket. Unlike the Falcon 9 and Falcon Heavy, the Superheavy Booster is reliant on existing launch infrastructure, or the Chopsticks, to catch the vehicle before it impacts the ground. For comparison, the NASA Space Launch System, or SLS Block 1, which is designed to transport humans to the moon, can only launch 95 metric tons and 4 astronauts into LEO. SLS does not require catch infrastructure because the core stage and solid rocket boosters, or SRBs, are non-reusable, therefore they splash down in the ocean. Criteria 2. Rapid reusability. Similarly to the Superheavy Booster, the Starship spacecraft can also land propulsively, however, without the need for the Chopsticks. Rather, Starship uses a combination of canards, a heat shield, and a landing burn of the Raptor engines to slow the vehicle's descent before performing a landing flip maneuver. The launch infrastructure is then used to load another Starship onto the Superheavy Booster via a crane, and the vehicle is prepped for the next launch within 8 hours. Unlike the 4 RS-25 rocket engines and 2 SRBs mounted to the SLS core stage, both the sea-level and vacuum-optimized Raptor engines used by Starship are fully reusable, thus are reignited throughout the mission. Criteria 3. Sustainable propellant. Starship will make the most of in-situ resource utilization, or ISRU. This essentially means using the resources on location rather than bringing extra resources which will occupy valuable launch mass. The Sabatier process will enable astronauts to use carbon dioxide and hydrogen, both of which are plentiful on Mars, to produce water and methane. Oxygen, which is extracted from the water, and methane produced by the Sabatier reaction, can be used to refuel Starship. The Sabatier process, powered by solar panels and batteries, can also be used on Earth to sustainably refuel Starship with zero impact on the environment. Even though liquid hydrogen, the main propellant for the SLS, can also be produced on Mars, SLS has no refueling capabilities once launched. Criteria 4. Low manufacturing and launch cost. Starship costs approximately $2 million to manufacture and launch due to its reusability. The NASA SLS cost $4 billion to manufacture and launch because of its single launch optimized design. That's 2,000 times more expensive per launch than Starship. To put this absurdity into perspective, here is an example flying aboard a non-reusable Boeing 747 jet. You pay for a ticket priced at $913,461 to cover the cost of the jet. On approach to your destination, you and your fellow passengers jump out of the aircraft and safely parachute onto the runway, leaving the 747 to crash into the ocean. In reality, the 747 is reusable, so during its 27-year operational lifespan, the aircraft endures 35,000 pressurization cycles, approximately 135,000 flight hours, and experiences a turnaround time of between 90 minutes between flights. This level of continuous, uninterrupted usage must be replicated with launch vehicles of the future for this industry to become commercially viable. To further illustrate the capabilities of Starship compared to existing rockets, we can explore a hypothetical scenario of launching the ISS, or the International Space Station. The ISS is currently the largest human-made structure in space, with a mass of 419,700 kilograms. The collective launch cost for all ISS components, launched piece by piece using the NASA Space Transportation System, commonly referred to as the Space Shuttle, the Russian Soyuz and Russian Proton launch vehicles, were an estimated $6.3 billion. If Starship were used to launch all ISS components, it would cost just shy of $8.4 million. That's a 750 times reduction in launch cost. It will be interesting to see whether NASA continues to develop a non-reusable launch vehicle for the future of the SLS program, especially because SpaceX and other private launch providers, such as Rocket Lab and Relativity Space, are pursuing reusable rockets. We would like to know your thoughts. Could NASA even develop a reusable SLS, or should they rely entirely on Starship for future missions? Let us know in the comments below. With that said, if you would like to gain a more in-depth understanding of innovative companies and disruptive technologies, then feel free to check out our weekly newsletter, linked below. Also be sure to click the video on screen now, as it contains an exceedingly powerful message which will assist you on your investing journey.